Lesson 2. Welcome to Lesson 2, which is talking about chords and arcs. In this lesson, we will learn how to use the congruent chords, arcs, and central angle, and how to use perpendicular bisectors to a chord. Let's see now today how can we use the congruent chords, arcs, and central angles. Now, what is the chord? The chord is a line segment that's endpoint on a circle. This is endpoint P, this is endpoint Q, and the line segments between PQ is a chord. And an arc, which is a curve that's their endpoint, is connecting between these two endpoints. We call them arc. So both of them has the two ending points PQ. But P arc, PQ, it is a curve. So I write it as the curve of the arc PQ because it's a curve, which will be an arc. And PQ, since it is a line segment, we called it a chord. So both of them have the same endpoint, but the curve is an arc and the line segment is a chord.
And teacher, the other side also an arc, right?
Yes, yeah. You mean this one here?
Yeah.
Yes, or with that.
This is a major arc, right? And that's a minor arc.
Minor arc, yeah.
Okay,
so,
thank you, teacher.
You're welcome. So PQ is an arc, P the chord, P the line segment PQ is a chord. Now, let's see now our new theorem here. Within a circle or in a congruent circles. So we can say within a same circle or in two congruent circles, the congruent central angles have congruent arcs. What does it mean? Look at the circle here. In this circle here, or within the same circle here, the angle, here we have AB, arc AB, and here we have an arc CD. This theorem, it told me that if the angle AOB, which is this central angle, is congruent with the angle COD, that means the arc AB is congruent to CD. Now, did you remember in geometry? Yeah, in chapter this chapter 10, we said that the measure of the angle of the central angle is the measure of an arc. So, as an example, if this is 15, this will be 15. And if this is 15, this one which will be 15 because they have to share the same sides of the same sides. Yeah, okay. Of the same lines. I mean, they are surrounding by two same lines. So if this is 50, this one will be 50. And if this is 50, CD, it will be 52. Here, in other words, that if the angle AOB is congruent to COD, that means their arcs are congruent. Where's the arc of the angle AOB? It is AB. And there, where's the arc of COD? It is CD, will be congruent. This is our theorem here. So within a circle or two congruent circles, if we have congruent central angle, so that means we have congruent arc. Now let's see the converse of the theorem. The converse say, if there are two congruent arcs, if AB is congruent to BC to DC, if AB is congruent to DC, that means the central angle AOB is congruent to the central angle DOC. Okay? If we have two angles that they are congruent, like AOB and COD, if the two of them are congruent, so their arcs will be congruent. Is it clear?
Yes, teacher.
Yes.
Yes.
Okay. Or within two congruent circles. What does it mean? Like if you have these two circles here, now here we have two circles, one with a center O and the other with a center P. If I told you that AOC, the angle of AOC is congruent to BPD, sorry, okay, if they are congruent, so AC will be congruent to BD. If I'm talking about the two congruent circles, so we can use the same theorem. To a central angle are congruent, so their arc will be congruent. Let's see now to theorem 12.5 and theorem 12.6. In 12.5 here, within a circle, in the same circle and with two congruent circles, congruent central angle have congruent chords. So the first in 12.4, we say that two central angle have two congruent arc. Here, two central angle have two congruent chords. So, and also it's inverse. So that's mean if AOB, angle AOB is congruent with the angle COD, that's mean the chord AB is congruent or will be congruent to CD. And it's converse like the previous one. If the two chords AB and CD are congruent to each other, so that means their central angle will be congruent. Is it clear?
Yeah.
Yes.
Yeah.
Okay. Let's see now the 12.6 here.
Teacher?
Yes.
Teacher, can you repeat what do you mean about the congruent circle? Like you mean if they have the same chord?
Like
And
this one, here the previous one.
yeah, like when we have congruent circle, so we have congruent chord. I don't know what.
This one or this one?
Yeah, this one.
Here, 12.5.
Yeah.